Hey everyone. Just a shout out as Phil and a couple of people mentioned earlier today. I'm up here because I submitted a talking paper last year and won top paper award. So I was an invited speaker. So if you have never, or if you're interested in trying out the speaking circuit, this is a great conference to do so. So what I'm going to talk to you today is about being nimble and how to enable your software testing team in doing that, right? So, what are we going to talk about? We're going to just talk about what is nimble. I kind of like to say this is Agile 2.0, 3.0, 4.0. It's what happens when you are really getting your consistency around your Agile practices. And now you become even more hyper efficient or optimized by becoming nimble with that. So we're applying some of those Agile efficiency approaches to not only the testing team and optimizing your testing team, but really all areas of the SDLC. And then we're going to talk about the three approaches to how to build, grow, and maintain your testing practices. And we'll talk a little bit about those three approaches a little bit later. We're going to talk about what are they good for, and sometimes even more importantly, what are they not good for? When does one of those approaches really not apply to your testing team, either as a test leader, test manager, or someone who may be exploring different ways in how companies have organized their testing teams. So we're going to tie in those approaches. We're going to talk about what they're good for and maybe what they're not good for. And then we're going to talk about the GCD approach, the greatest common denominator approach. And this has been an approach and tool that I've used almost 2/3 of my very long career in software testing, quality assurance, and quality engineering. And we're going to talk a little bit about how to apply that GCD approach to something that should be pretty common around how we as testers, managers, leaders, or folks who interact with and influence the testing teams, you'll kind of recognize some of these major activities that will apply the GCD approach to. And then ideally, we're going to have some collaborative conversation throughout. So I encourage you to share your thoughts, to share your opinions and feedback, also ask questions throughout the conversation. For those of you who are online, I will make sure to repeat the question. And if I don't, somebody please remind me. So let's get started. So let's talk a little bit about what is Nimble. Nimble really is kind of a collection of things and activities. So the idea is that we start small. After we start small, we pick a small project, something that might not be pervasive throughout technology or something that might be a new idea or a new approach that someone's thinking about. We start small. We take maybe a couple of representatives of teams or practices within your SDLC or technology organization, and we try something. We apply that. How does this work? Then we see how it works. We take measurements and we observe that, and then we study it. Say, is there a better way to do this? We gather that data, we scale it out, up, down, left, right, top, bottom, and then we rinse and repeat. And really, that nimble idea is really for folks who are mature in maybe their software development, test engineering, testing skills, either or in their career. And there are people who have a high threshold for experimentation. We don't necessarily want to try being nimble or maybe this approach with people who are adverse to change. And that's why we kind of take those representations of those practices and become more experimental. One of the best things that I love when I interview with companies or I consult with companies is their threshold for failure. We've always been, I think, almost mechanized to believe that failure is something really wrong, right? Like if we fail, if we find a bug or something, sometimes that has an adverse effect or becomes an emotional response for those people. I love when companies and leaders of organizations within those companies have a high threshold for failure, because as we know, the more we try something, the more we will likely fail, but the better and higher quality we will be. So being nimble kind of gathers all of these types of characteristics, and it becomes a method or an approach, or in some cases a model in which to apply to how we look at forming and building teams. So The idea around being nimble is that we can pivot quickly by starting small. It's much easier to make fast and rapid changes with a smaller group of people or processes or tools rather than a large organization. I can speak very confidently to this. I'm right in the process right now of handling both a transformation from quality assurance to quality engineering with a team at Campminder, as well as applying some more efficient approaches to their agile transformation processes. These are very, very relevant to what I'm doing on the day to day. So my memory is very fresh with some of these. And as always, I've experimented. I've had a lot of failures, but I've also had a lot of successes with this. So the idea is you're not able to be as nimble if you're unable to pivot quickly when those failures come in. So we want to fail early and fail often so that we can learn from them and ideally save those bigger, more catastrophic kind of mistakes for way earlier on so that they're less impactful and less risk. So when we apply that to nimble leads to being able to pivot quickly. Pivoting now then leads to being optimized. And optimization is really hyper efficiency. If you've ever heard me talk or read anything that I've written in the past few years, efficiency, and as part of my bio, efficiency is one of those tenets. The idea is to not just look at where we can be efficient or where we are inefficient, but it's really taking that second or third step to say, once we're inefficient, we identify where we're inefficient, we address that inefficiency, and ideally, there is some sort of a time savings with removing that inefficiency. We don't stop there. We come in and we add to our plate of things because ideally we have just received, we have a net new of time that's available to us to perhaps add more things to our plate, things that we might not have had the time to do previously. So it's always looking at hyper efficiency for optimization. Nimble and being able to pivot quickly lead to that optimization. And then optimization, of course, leads to us being able to best support and enable the delivery efforts within the SDLC. So when we think about that, that leads to kind of where I am right now in my career. For most of my career, I've spent again in software testing, quality assurance, and quality engineering. And now I have this new role of head of technology enablement. But what is that? How many of you are in a technology enablement or an enablement practice? I didn't think so. I would have been surprised if somebody raised their hand. It is fairly new. This is the second company where enablement has been a practice within. And quite honestly, it's because I had a very fortunate interview with one of the CEO and founder, as well as the CTO. And I pitched the idea of enablement as being quality engineering kind of 2.0, where quality is applied to the entire SDLC and we use that quality type of mindset to apply it to all the practices or representation within your SDLC. And by practices or representation, I'm talking about software engineers, architects, product, platform engineers, DevOps engineers, testers, all of the roles that make up your technology organization. Enablement really kind of sits now across all of those. And we look at people, process, and tools to make that SDLC and all the components of all three of those areas, people, of course, being first, the processes that we either create or adhere to, and then we ensure that the tooling that we use in order to make both of those activities more efficient are being well used, being efficient, and optimize in their use and apply that across all of that technology organization, or in some cases across the company. So in my organization, enablement actually has four functions. There's the quality engineering, the testers, that function in there, and they sit across our SDLC. We have AI enablement. How do we enable technology and the rest of the company on using AI assisted tools, approaches? And then we have our agile enablement? How do we apply our processes and our hyper efficient, agile practices across technology and perhaps across other organizations within the company? And then our release management. So, all four of those practices right now roll up under the enablement function. So, for those of you who may be interested and want to explore a little bit about enablement, come find me. This is a very new and emerging kind of practice within companies. I'm really excited to kind of be at a little bit at the forefront of being able to define that. And personally, since I have focused most of my career on the testing standpoint, I think this is a great way to meld all of that quality aspect and mindset that I've had as a tester and as a leader in our industry and apply that to something that could be very widely adopted across not just the technology organization, but other orgs within the company. So I'm excited to see where this new and emerging field goes, and I'd love to hear from you and some of your experiences with it, or asking questions and collaborate on that. So when we think about that, so I wanted to kind of pause there and talk about kind of what I've been doing for the last couple of years in quality engineering is really considering where does the testing practice fit? Where should they fit? So that really kind of got to the understanding of, well, let's figure out where and how teams are initially defined and how they're made up. So what are the approaches? Centralized, right? We kind of call this one the traditional one. This generally looks like a QA or QE testing leader in place. I have been that leader. Some of you may have been that leaders. How many of you lead an entire QA practice or team or organization? How many of your leaders or managers, directors, VPs above? Okay, great. So some of you, how many of you would consider yourself individual contributors? You are part of that testing team, either as a focusing on some sort of skill set. Okay, great. About another third of you or so. And then the others who haven't raised their hands, perhaps you are outside of a testing team, but work with testers on the day to day or have some sort of influence or oversight into the testing activities. Doesn't matter. The good thing is this model hopefully applies to many other types of test teams within your technology organization and within your QA or QE team in general. So the traditional or the centralized model. QA or QE testers usually report into that leader, whether they are a manager and they have all of the QA or QE folks reporting to them directly, or they may have other managers or leads that kind of manage that, take on both the HR responsibilities as well as career development and enhancement, right? How many of you kind of identify with the more centralized model? Okay. All right. So some of you, great. So the idea here is that the entire testing practice is both defined and managed by that central leader and their organization that they've built in there, as well as the competency and the professional and career development and enhancement. Process tools are also managed by that same leader and that same organization. Okay, so that's the centralized, probably very familiar to most of you. Most of my career, I have been in that centralized model, either working in as an individual contributor or helping build, form, maintain other centralized QA or QE teams within companies that I've either consulted for or worked with. So the second approach, the decentralized model, which is what we kind of call the fast and the furious, right? What does this look like? Testing is expected to be done by the entire team or designated roles. Generally speaking, the developers or software engineers test each other's code. They apply some sort of guideline in there, generally not very documented in there, but they are expected to because there is no necessarily centralized practice or role within that. The practice of testing is likely defined by the individual engineering managers on that, right? So you might have an engineering manager where all engineers, to include the quality engineers or testers, report into that direct manager. And that manager has two or more practices in which they manage and help with career and professional development, not necessarily experts in testing or experts in architecture, but they have managed all of that engineering a competency within one leader at the team level. So generally an engineering manager. Um, it is likely not consistent across all engineering managers, though. So you might have one engineering manager that might put emphasis on a certain type of testing, and maybe they emphasize more test automation rather than unscripted type of testing there. But the idea is that that manager runs the show for that team, and it sometimes becomes inconsistent between manager, and manager. So when we think about that, again, process and tools are likely going to be managed by that one individual manager, and they will likely be somebody from the software engineering background, and probably not having much expertise within testing, right? So they're almost always going to be a little bit more biased to software engineering, and they're probably going to want to emphasize getting code out faster and quicker rather than putting some of the rigor around that testing and higher quality aspect. Both of these are very common and very important types of models to be able to put your approach in there. So it's good to always know what type of approach you're looking at. So then the third one, of course, is the hybrid, right? This is kind of what we lovingly call moving into maturity. This is when perhaps a startup is looking at maturing their testing organization. They're looking at investing more people with testing expertise, whether that is a leader within there that owns the practice, or whether it is specific skilled types of testers that come onto the team. They're looking at the need for maturity. They may also have testing is owned or expected to be done by the entire team, but there's generally somebody like a quality engineer who is consultative with them, who can help guide them into the types of testing that should be happening, and also help them measure that, and sometimes provide a service of writing those tests for the folks on the team, in addition to sharing some of those responsibilities. Um, in the hybrid model, again, companies are generally looking at investing in a leader, either not necessarily a centralized leader, but they could be, or they might be moving into that centralized approach. But they are having somebody with expertise that has come in, expertise and competency within testing, who can help guide and build that more centralized practice to where the management of those people may still belong with the engineering managers that have multiple practices reporting into them, but that leader exists to provide service and to be able to provide that practice, and then uses those engineering managers to make sure that those are rolled out to individuals. And again, the processes and tools are beginning to mature. They may belong within that central leader, but they're still going to be managed and have accountability within that engineering manager over the specific project team in there. So let's talk about so now, actually, before I go on to this one, so how many of you, now that you've heard the three types of approaches, how many of you we'll ask the question again, how many of you are in that centralized approach right now? Are there more hands? Okay, less hands. Okay. How many of you are in the decentralized approach? Okay. And then how many of you are in the hybrid? All right. Still not seeing a lot of hands here. So I will make sure I have to figure out the question to get everybody's hand raising up. But so you can see neither one of them is better or worse than the other. It really depends on the maturity of the organization and how much investment, i.e., money, is a company or an organization is willing to invest in those types of practices. All of these are relevant. All of these are good. It's now understanding which model and approach do you have, which model or approach do you want to be in, and which makes sense for the entire organization, or specifically for technology and your teams that you support. So let's talk a little bit about this. So centralized. When there's a need to have an independent or team role validated before release, if you're a highly regulated industry, finance, medical, devices, anything like that where there's highly regulated, especially if there's a need for a third party validation, the centralized approach might be that right approach for you. When testing is complex, or there are many integrations, or perhaps you have a very, very deep and older code base where integrations and lots of regressions happen on the daily, where you might need to consider that centralized model where there is a role or one or more roles that take on most of the responsibility of the testing on the team, but also serve as that expert for other members of the team who may need or want to join in, or in most cases, if they want to start developing their own tests. When the teams are made up of more than 4 software engineers, and I don't necessarily want this to be one of those kind of hard and fast rules, but in my experience, when you have more than 4 software engineers without on a particular team, without having an owner of testing who has either that deep expertise or competency, you will likely run into situations where documentation is not going to be there, it's not going to be consistent, and you are very dependent on software engineers sharing with you what they tested rather than sharing those via documented tests like unit and integration tests. But as we know, for those of you who've worked with outstanding software engineers, those unit and integration tests that they document are important, but I promise you that that's not the only testing that those great and excellent engineers are doing. They're going to be validating on their own in addition, but those validation steps outside of those unit and integration tests are almost always not documented. They're never documented, or very rarely are they documented. So that takes a conversation. Yes.
I'd like to understand now, opening of that centralized thing, you mentioned that it's highly regulated environment, right? It's highly regulated, which means there's some regulation coming from outside. And if in that situation, I would think that there would be, with respect to you, that there would be more documentation as opposed to less.
Right. So the question was, or the comment was that in highly regulated fields like that there would be more documentation that comes out of that. Right. Exactly. And I think and that is basically what essentially you're going to see more documented processes, more documented tests in a centralized in a centralized approach, because those individuals are experts in that test documentation. So yes, you will see more documentation in a centralized approach.
Both for testing and designing.
Correct. Yes. Yep. And by the way, for those of you that both for the testing, design, and the engineering aspects of that. Yep. So again, going back to that 4 software engineers is not necessarily a hard and fast rule. It is one thing that I've seen in my experience that once we get to that point, a centralized model might be one to start considering when you start growing your software engineering team, especially if you have multiple engineering teams that are working either within or close to upstream, downstream the same code base. And then when the number of defects being reported by users or others that are on behalf of the users is high, that means that's probably that those flags are that you're going to be seeing more regressions. That means likely for seeing more regressions, that the developers or software engineers are likely not going to the level of regression validation that they should be. And by the way, I always like to kind of make this quote here. I am a fan of QA testing, not owning regression testing. I feel that the software engineers should be responsible for making sure that there are no regressions in their code base. In a lot of ways, we've kind of inserted ourselves as QA to kind of be that enabler or that crutch in some cases for developers not really paying attention to that. That responsibility has kind of fallen on our shoulders. It has really been our responsibility for many, many, many years, certainly since I started my career in the late 90s. So I would challenge you, and we'll talk a little bit about this, the TAS approach, the test as a service approach, on how we can actually give back the validation back to the software engineers and let them validate that they haven't regressed their own code versus it being passed off to the QA team. So we'll talk a little bit about that. So the other reason, where it's good for the centralized model is when software engineers are delivering at a very high velocity, and decreasing that velocity would result in high stakes losses. You want to keep them coding, you want to keep them writing that code, and where you're going to add another expert onto the team to assist and help them so that they can keep on with that high velocity. Okay, so decentralized, what's that good for? When time to market is very important, this looks very much like startups. Startups where there's that jack of all trades kind of approach there, where you may be a software engineer, but you may also be releasing, or you may also be supporting. You might be tier 2 or tier 3 support or something like that. That's very common in the startup world. When time to market is very important, that decentralized approach might be the right approach to apply to that company or to your organization. When teams are independent of each other or isolated, there is very little, if any, dependencies, again, upstream or downstream from team to team, and they're very isolated, and they can release and deploy at will or following their own standards and guidelines, because there are no dependencies and very little risk of what they're producing and deploying on other teams. Perhaps when teams are truly practicing Kanban with limits. When I say truly practicing that, it's really following those guidelines of Kanban, not necessarily just to have the one card for one person or with limits, then calling it Kanban. It's really adopting and embracing the entire approach of Kanban. In those cases, those teams tend to be a little bit more mature and can handle that more decentralized approach to testing in there. And then when high quality is less important, not that it's not important, but less important than rapid delivery. Again, think about startup times. Time to market is going to be much more important in a lot of those cases than perhaps the high quality and rigor that a centralized testing or QA approach brings on. So then the hybrid model. So what is that good for? When teams have met that well-oiled machine criteria, everybody kind of understand that, where you've worked on teams, I'm assuming everybody's worked on that team where you remember them for years and years after you've worked with them. Everything is clicking, you're highly collaborative, conversations are free-flowing, you're sharing ideas, there is not an us versus them kind of mentality. Everybody has an equal seat at the table. When you've reached that maturity with your teams or a team, might be a really good approach for those types of teams in your organization. When technical debt is managed and represented either on the roadmap or ideally in backlogs. When technical debt is known that we are going to accrue debt, but how well and how quickly is that technical debt addressed? That's going to be a great indicator of whether or not that hybrid testing approach might apply to that team. When team members move from team to team, or when new team members are being added, they're seeing rapid growth. You might be bringing in a contracting or an outsourced partner, distributed or nearshore, offshore type of thing. When you're moving teams from team members from team to team to team, that hybrid approach might be a good approach for you to consider with your testing. So, what are they not good for? Let's talk a little bit about that. Centralized generally is a push rather than a pull model. Again, the more you have somebody that is focused on a particular role like testing, sometimes the software engineers might forget some of their practices, and they might just want to push the cards over to your column to indicate when testing is ready, rather than having that conversation, allowing you to pull that card through once that criteria is being met. They tend to own quality, right? So most of us probably have the term quality in our title, quality assurance, quality engineering, something similar. Sometimes that gives the perception that now quality or testing is only owned by that one particular group or representation or practice, right? I'm a developer. I have somebody with a test for quality in their title. I'm going to quickly get this code out. and they'll tell me what's wrong with the code, right? That's probably very familiar in there. And sometimes, again, just by creating that extra role, that centralized model may also enable some bad behaviors from the folks who are left, the ones who are responsible truly for the code quality. We're responsible for sharing the information with them as we interact with them. Okay, so what is a decentralized model good for? Or not good for, excuse me. When there's generally no consistent reporting across teams. It's not a great, it's not a great way if there is not a need or a desire for that consistent reporting. Um, Standards and guidelines tend to go to the wayside when schedules get tight. So think about the engineering manager who is probably coming from a software engineering background and now has responsibilities and manages multiple practices: quality, platform, DevOps, software engineers, architecture in some ways. Most cases, when schedules get tight, testing generally goes to the wayside a little bit. You want that strong advocate to be able to advocate for the testing that needs to happen. In a decentralized approach, you might not get that type of advocacy and support from that engineering manager if they're also responsible for delivering code or delivering solutions on time. In most cases, the trade-offs might be that the testing falls to the wayside, or the original estimates or time that we wanted to spend on testing might be decreased. And then when members move from team to team more frequently, in this case, it takes a lot more onboarding for them to get used to an engineering manager from engineering manager. If we don't have that consistent centralized practice within that leader that is owning and communicating all of the standards and guidelines that happen within our testing organization. So in the hybrid model, right? When is it not a great idea to perhaps have that hybrid approach in? So when the newer or beginner associate level team members make up your teams, if you're kind of bringing folks in from coding boot camp, whether there's a reason for lower investment or lower pay for whatever reason in there, when most of your team is made up of junior or associate level members, it's hard for them to be able to balance and context switch between those two models and approaches. When team members are highly distributed, if you've got nearshore, offshore, outsource, different contractors or different folks from different companies who are making that hybrid model might not be great, because what you're really seeking for is an easy and consistent way to plug folks in, which is where that centralized model generally comes in and is highly important. And then if there are very little or no coding standards that are documented and being adhered to by your software engineers. I'm going to pause here. I'm going to ask you a question. How many of you are very familiar with your software engineer counterparts, unit and integration guidelines and standards? Okay. Yeah, what's that?
Yeah, because there are none. So
okay, yep, so there are none, right? That's almost, yes, exactly, right. So most of you did not raise your hands. For those of you in the front, you didn't see, I can see everybody here. Most of you did not raise your hand. So for those of you who didn't raise your hands, is it because A, there are no standards and guidelines? And if that's the case, raise your hands. Okay. Or is it because there might be a skill gap in understanding what unit or integration tests are in place? Anybody fit that? Okay. Or is it because that information is not being shared, or you're unable to tap into that, whether it's a licensing issue or something like that? You don't have access to see that unit and integration testing. Okay, so yeah, for those of you who raised your hand, probably about a third answering to that, which is actually pretty telling, because that's basically when they ask that question at other conferences, that tends to be the distribution. When we don't have access to what our software engineers are doing as to validate, we assume nothing is being done. And when we assume nothing is being done, we take on almost the entire burden or the entire responsibility of testing on behalf of our software engineers simply because we either don't have access, we don't have the right conversations to know what's happening, or we simply don't understand how that testing is being done. So again, we make the assumption and we become duplicative in how we wind up testing. I promise you that we are duplicating tests, but we just don't know which tests are duplicating because we don't have access to those tests, right? There's a whole other talk that I do about quality engineering and kind of what their role is and being consultative and understanding the landscape of testing. Again, we can talk about that later in the hallway kind of conversations. So let's talk a little bit about the GCD approach, right? Greatest common denominator. I think everybody that's probably a very familiar term. You've taken any kind of middle school or elementary school math. Greatest common denominator is probably familiar to you. And anybody never heard of that? Okay, right. So everybody here has heard of that term in here. I kind of used it to apply here. Basically, greatest common denominator, the approach means that we go down to the very basic building blocks of the right information to find alignment with the people or team or group of people that we're talking with, right? We have to find that commonality, and that is essentially the greatest common denominator approach. So the way that we would apply something like this is we would say, okay, as I come in and I'm a consultant in a company and I want to know, how are we doing testing here? Talk me through how this company, how you individually are doing testing. What is your approach, right? So when we get to the point, we agree that we can basically, in our day to day and our responsibilities of being testers, they really kind of fall into into three categories. The first category being test management, right? What and how and where do we store the tests that we will be eventually executing against these? Then it's the test execution. Once those tests are created, or once we have that strategy created after we've had all those collaborative conversations with all of our counterparts on the teams, what and how will we do this? How will we execute those tests? Or more importantly, how will we test this solution that will eventually be coming our way? And then how will we report on those? So I'll pause there. So what I'm saying here is that as a tester, all of our responsibilities that we do as a full-fledged tester in good standing, all those activities can roll under one of those three categories. Does anyone disagree with that? Is there anything that I might have missed that doesn't fall nicely into one of those things? Okay, right. Yes.
There's one question.
Oh, one question.
Question from online. Hello, is this working? Starting up. There's a question from Anna from online. The three types: centralized, decentralized, and hybrid. Which type would work best in the situation where the company is using a strategical partner to do the testing?
In that case, if they're using a partner that is strategic and I'm assuming has expertise in testing, I would almost guarantee that they are probably following a centralized model because the expertise is there and they become the experts on that and then apply that to their client or their partner, which they're partnering up with and working with. Good question. All right, so kind of going back to the big three: test management, test execution, and the reporting on any of those activities as we're doing one or both of those activities, right? So what's the balance? Well, how much time do we spend on test management or test execution or the reporting on there? I'm always asked that question of what is the balance? This is the only ratio that I like. It's called the 10-80-10. And if you apply it, this might be a stretch goal for those of you, but when you look about as testers, the most important thing that we can be doing is interacting with the software as we are looking at that in both an unscripted and scripted manner. We want to see that number in the middle, which represents the test execution. So the 10 on the left is the test management, the 80 in the middle is the test execution, and then the 10 on the right is the reporting on those activities. Again, this might be a stretch goal. You may need to focus more on the test management, the organization, and the writing of those tests a little bit more. The idea here is that that middle number should always be much higher than either of the numbers on the left or the right, because as testers, that is where we provide the most values by interacting with those solutions or preparing and having those conversations for when we do interact with those solutions and test it, right? So when we think about that, if you are spending much more time on either the management portion of it or the reporting portion of it, look and see which of those things might be duplication. If you think perhaps you don't know what your developers are doing on their own part, if they're validating things on their end, have that conversation if it's not documented and start removing those tests or at least deprioritizing that so that you can always increase that middle number. So this is a good stretch goal for those of you. You might look something like 40, 50, 10 or something right now, but the idea is to decrease the left and right and increase the one in the middle. So how do we apply this? Yes. Yes. This is an approach that it will apply to either any one of those approaches. Yes, exactly. The question was, does it apply to all three of the approaches that we talked to? The answer is yes. So let's dig a little bit deeper. How would we apply the GCD approach to test management? So how do we categorize this? The way that I look at it is the highest, when we think about test management, we are either looking at scripted tests or unscripted testing, right? And those are equal. Scripted tests look like test cases that are written in a traditional test case management tool, where the eventual execution of those tests is done by that human, that tester. Or we may be building them in a framework or a tool, and those are likely all automated. Both of those are scripted testing, because what we're doing is we're using a set of instructions to and to validate what an expected result, right? So we're following a list of instructions. The alternative to that is the unscripted testing. That is exploratory, ad hoc. We are more in a creative and less scripted way, exploring and interacting with the software and really looking for user advocacy types of testing in there. The idea is that one or the other is not necessarily more or less important than the other. They're equally important. And you need to make the determination of what the risk is if you decide to emphasize one or the other over the other one. The idea is that both of those should be balanced and that we rely on and embrace tools and processes so that we can be much more interactive with the exploratory testing, which is where our humans or our users are going to be ideally interacting with it as well. So things that we should apply to that. If we're running a test case by a human, a tester, more than once throughout a cycle of testing, that should or could be considered something to be automated. Not necessarily that it should be or would be automated at that time, but that should be a trigger or a flag for you when you're looking at being hyper efficient in your own testing approach. In test management. So the other things that we want to put in here is we want to make sure that there's a standard guidelines. We like to call these prime time guidelines for automation. When we think about now the scripted testing from an automation standpoint using a tool or framework here. There are prime time guidelines that we want to apply, that anyone that's using this tool, or whether it's a commercial grade or an open source or something homemade from that team, that we apply those prime time guidelines. Anyone that's using this tool, we want to use it in this way and in this manner. So if we don't have those guidelines created, that's something that we should be considering investing in so that we take the guessing game out of how we should be using it, especially if we go back to the developers and ask them to start participating in some of that scripting, especially if there's perhaps a skills gap between automation and not having that skill or expertise doing that. So we want to start small. So now we're going to apply the GCD approach to how do we create tests? How do we want those to look? The idea is that everybody has heard of the term smoke test, right? Essentially, it's kind of the same. I think we would probably all define it. It's basically the basic critical functionality. Depends on what your organization, how they define it. I like to define it as adhering to the CRUD actions: create, read, update, delete. That's basically a building block of functionality and actions that are associated with it. So if we can apply that FRUD approach to a smoke test, that's something that's easily defined and easily aligned with everyone that's going to be applying that definition. So we start small. We build smoke tests first, and we do not automate anything else until those smoke tests not only are created, but that they meet our prime time guidelines. They're running in the pipeline, they're centralized, they're passing, they don't go to some rogue isolated Slack channel with only 2 people looking at it. They go to a place where the entire team is looking at that. If you align your first set of test automation to something as critical as a smoke test, I promise you those failures are going to be very, very interesting to everyone on the team. Everyone's going to want to know if that basic CRUD action is failing in some way, right? Lots of times we have that kind of rogue and isolated Slack channel where those results go to, and it's really only 1 or 2 folks that are looking at it. It's probably only the QA team rather than everyone else on the team, right? So then we create those stories and we make sure that as we're in there, we're automating it, we tie the definition of done of that story so that that automation of at least the smoke test is actually done and do. So we don't move that card out of that in test column, and we don't consider the work complete until that smoke test has been automated and adhering to our prime time guidelines. So then these other 2 are things, once you've got those smoke tests in and running and it's consistent, you've got some good repetitions there, then you can start expanding it. Here are a couple of areas that you might want to look at expanding that to. So test execution. How do we apply the TCD approach to how and when do we test? Again, I kind of talked a little bit about this before, but we want to have that balance between scripted and unscripted testing. Both are equally important. Sometimes one is going to be more important than the other, depending on where you are. But generally speaking, they should balance out to be spending of equal importance throughout a longer duration of time. Scripted tests, by the way, if they're centralized and they're being looked at and reviewed, they are part of explicit information that belongs to the team. The same token as I mentioned that I believe that software engineers should be responsible for validating that no regressions exist. I also believe that any documentation to include tests should also be part of archived information so that you're writing those tests while that developer, ideally before, is writing their code. And their responsibility is to be referencing your tests so that they're writing their code so that those tests pass. It sounds like a little bit of a TDD, test-driven development kind of model or approach there. But the idea is just because the tests are coming from a different practice within the team, and perhaps that person on the team is the one responsible for running them, that information should be referenceable and should be expected to be reviewed and looked at from everybody that's on that team so that it doesn't, all the responsibility doesn't roll onto that tester that's responsible for doing that. And again, so available to the team, these are all prime time guidelines. These tests are centralized. They're in a tool that's well understood and the software engineers or anyone on the team can run those tests as needed. And more importantly, that they're tied to how the software engineers are organized. And that's kind of the premise of the tests as a service approach that I've been really kind of honing in on for the last couple of years. The idea is if I say that devs should be responsible for validating that there are no regressions, our responsibility is to provide them those tests and that guidance so that they can do it on their own, and that we start organizing those tests to make it easier for them to do that so that when we get that solution, when it's time for us to start testing it, we're focused on the highest value and highest importance and likely exploring that solution much more in an unscripted manner than that scripted manner because those tests have been run by someone to the left of us. So reporting. Again, I'll kind of go through this a little bit quicker here. Really, the idea about reporting, if you look at that 10-80-10, we want to make sure that we're not spending too much time on reporting. We want to understand what's important for us to highlight, and what's important for the people to know. And let's standardize that and keep it in a much more self-service manner. If we're running or expected to give status reports every day or every week on the status of testing, and it's repetitive behavior and it takes a lot of time out, consider doing some sort of an executive view or summary on all of that. So again, the idea is you want to make sure that you own the reporting and that it's plugged in and valuable to the folks that you are talking with on the day to day. Sharing your information during the time of your writing those tests. Obviously, sharing information as you're interacting with the software or testing, and defect reports and sharing of information, having collaborative conversations with your software engineers, defects, issues, and bugs. And then user advocacy. And this is one of those areas that we will heighten and increase if we look at hyper efficiencies and removing things that, again, might be duplicated by somebody else on the team or that perhaps doesn't add value. Ideally, you are spending your time in the most valuable manner and sharing the right and appropriate information with your team together. So, one metric that we might want to consider is a new metric called, not a new metric, but I've been talking about this for a while, automated of automatable, A of A, right? We always get to that point. Many of the speakers have talked about this already, but we tend to get kind of measured by the percentage of test cases that are automated or a number of tests that are automated, as if the higher the percentage or the higher the number, the higher quality of that product. And for those of you who've been doing this for a while, we know that that's simply no correlation between the number of tests equaling a higher number or higher sets of quality for that solution, right? So we want to hone in on the right important things. If we can all agree that the smoke test is the most important piece of functionality, we tie our metrics to that so that things do not move out without that smoke test not only being in a passing state, but being run multiple times as part of the deployment and within the pipeline. So consider using that A of A as a metric that you might be able to show high value on your automation that takes us away from a simple percentage or a number of tests that are automated. So, and again, some of these areas, these might be very familiar. Create your own release or reporting criteria. What does that mean? Do you have a threshold of how many defects, the severity of those defects, how many of your test cases are in a passing state, how many defects are open and resolved, and is there a good understanding of how those issues will be resolved and addressed if the team chooses to go forward with a deployment without addressing those at that time. So, all right, so let's tie this all together. So what is nimble? We start small, we pivot and we try something new and again and again and again. And then we pivot and make sure that that's valuable. We always look back and make sure that that pivoting and that being nimble approach still applies just as much and is adding just as much value as when it was created. What are the approaches that we've had? We have the centralized, the decentralized, and the hybrid approach to testing. You all probably can figure out which of those approaches you are. More importantly, the fun stuff is what happens when you need to change the approach mid-flight. What happens if you're decentralized now, but there is an investment in a centralized model, or you are centralized now, which is what we're doing, and we're decentralizing that back in there. How do you approach that? Make sure that we categorize that stuff appropriately first so that you know which approach you are actually in and what the benefits and maybe not not so many of the benefits of moving from one or the other. Applying the GCD approach. Apply that GCD approach. We just used 3 examples: test management, test execution, and test reporting. The GCD approach can be applied to anything that you have on your plate, whether it is looking at new initiatives, adding new services to your, to your service offering as an organization or not. The idea is that we start small and then we build up. We find that commonality first, and we all agree that all of our day-to-day rolls up into one of those 3 areas: management, test management, execution, or reporting. And since we all agreed, or at least nobody disagreed, that becomes our common theme and our core. And we build up from there. And we always check in to make sure that we still have that alignment with all of the people that are involved, and especially those that are going to will take this on and implement it within their team. And then, of course, we have a couple of just measurements and metrics that may apply to you. I'm happy to talk more about this. So, with that said, I think, do we have enough time here, or do we?
It's pretty tight, but maybe 2 questions.
All right. Okay. Got it.
question: how breaks culture testing about developers to test since they are exist private?
Yep. So the question was, how do we push or encourage developers to test? This is always an interesting one because I would say that every engineering leader that I know fully expects and says that they have an expectation that the developers test, right? You're never going to have an engineering leader that says, oh no, we don't ever encourage testing from our developers. At that point, honestly, it becomes a conversation of we have an agreement as a team. And a lot of times you can apply a team agreements playbook. Part of my role under enablement, we're creating playbooks for these types of ceremonies like team agreements, where we talk about that. So we have, and the accountability is it's stated in a public manner in front of the team. And we agree to the level of testing that those developers are going to do. And once that is kind of publicly stated, and in the team agreements, then it becomes really their own accountability to do it. And if they're not doing it, then it takes the pressure off of the tester, pointed out, because they've agreed to it. And that really becomes a conversation between them and their manager or their lead to figure out why they're not doing something that they said they would and that they would hold accountable. Sometimes we use those agile ceremonies and playbooks to kind of help get those conversations so that it's not always the QA or QE that is hounding developers to test more and more and more. That really needs to come from that engineering leader.
One more quick question, anybody?
I don't want to get in front of everybody at lunch, so
Yes. Thank you, Melissa.
thank you.